Good morning, student. Good morning. Uh, is anybody is here? So I'm waiting for 1 minute, 1 or 2 minutes. Then we'll start today's session. Today, basically, we'll discuss about recursion. So just waiting. Let join some few more. Good morning, class. Good morning, Ankita. So, today, as we have planned, today we are beginning with the next chapter, that is recursion. So, first of all, we'll get one introduction of recursion, then we'll proceed further on the chapter. So, basically, recursion, this means actually recursion is a continuous topic of function chapter only. Whatever we have learned in the function chapter, it is one of the version of function, that is recursion. Why I am telling about function? Because the definition of recursion is self-calling function. Self-calling function means whenever a function calls itself, or sometime when a function calls some other functions, it can be termed as recursion. But it also has some properties. Yes, good morning, Aman. So we are beginning with recursion. So let's continue. So we know that whenever we are doing recursion means self-calling function. That means a function that is called from another function, or sometime a function is calling itself, that is termed as recursive function. So for example, we can understand this is a simple demonstration that def function 1, then within the function 1 another function 2 is called. So we can term this is a recursive type function, but obviously recursive function has a specific properties also, because it has some advantage as well as it has some disadvantage also. Time by time we will come to know. First of all, we have to understand the basic concept. So for example, before going to the depth of anything, or before going to the explanation of recursive function, we can understand by a simple example. For example, if we want to find factorial of a number, then we know that factorial of 5 is basically written as 5 into 4 into 3 into 2 into 1. In this way we can find the factorial. It will be 120. If you want to find the factorial of 4, so simply 4 into 3 into 2 into 1. Simply the multiplication or accumulated product will be multiplied from that number to number 1. This is the way of finding factorial. Now, how we can understand that this particular problem can be termed as or can be treated as recursion? Because you have to understand one thing in recursion, that same type of task is repeated. Same task is repeated means what? Here you can see multiplying or product of the numbers starting from the number to 1, it is continuously multiplying, it is continuously, and one task is we have to do, another task is here, you have to subtract the number by 1. So this type of, whenever we will use this type of concept, we can use recursive technique. If we go for another example, already we have discussed as a very brief about this first two example. Find the value of a to the power b using recursive code. So when we write a to the power b, what does it mean? Let's, for example, if we write, we want to find 2 to the power 4. This means what? We have to multiply the 2 for 4 times. We have to multiply 2 for 4 times. So that means ultimately we have to multiply, or we have to run a execution for 4 times, then 3 times, then 2 times, then 1 time. 4, 3, 2, 1. That means we are reducing, or sometime we can increase also. So whenever we are simply repeating ourselves, so that time we can use the recursive technique. So as I told, recursion has various structure. This is the first structure we can understand, that whenever a function calls another function, one function calls another function. This technique already we can use in the normal function chapter also. Just like for example, I want to find everything about, yes Ritesh, good morning. Suppose I want to find area. I have one function area. Within the area function, if I want to find separately area for circle, area for rectangle, area for square, so for each cases I can call distinct method. From one method I can call multiple method. This technique already we have learned. So this is actually called the recursive technique. Yes, already I can see 4 of you are present. Okay, so time by time more will join. So let's see. Let's proceed further. I am taking the second example, and this is the best example we can say. Just like def a, and from a is calling, we are calling a function only. So this is also self calling function. We can understand def a is the function, and a is calling itself. So this is called self calling function. It is just type of this, just it is calling self type of self function, self itself. Then we'll go for the next example. Just like def a, within a we are calling b function, and from def b we are calling a function. So just this is also a type of recursive function. But already yesterday we have seen in practical session that this type of function will go endlessly. So basically this is recursive function that can be understood, but these are not fruitful code. Fruitful means whenever you will get any result and that will be used for you, you can use, that are only called fruitful function. So this type of code are basically not fruitful. So today we'll discuss some more about it. Already we know that what is the definition of recursion. Recursion means when a function calls itself, or sometime from a function it calls another function, but it goes on or it repeats the tasks, that is called recursion. But recursion has a two variation. One is direct variation, another is indirect variation. So direct is nothing but whenever a function calls itself. Here is a function, a is calling a only, means itself. And indirect means from one function it is calling another, and another function is calling its caller function. That means a is now caller function of b, and here b is calling a function. So first of all, a is the caller function of b, then b is calling a, that means now b becomes the caller function, caller, caller function, which calls another function, those are called caller function. So basically these are two types of recursion. One thing I need to clarify to all of you, that this chapter, whenever today we are beginning with this chapter recursion, this is very practical things. For very quite few sum only we can go for recursion, because if we go for each sum, if we want to convert each and every programming concept into recursive technique, either it will not be possible, or sometime you will face that it is very much typical to make it as a recursive code. But obviously in some cases, in few cases, it will be helpful. So whenever we will go through our chapter, we will learn few concepts, what are the ways, how you can create a recursive function, and obviously we will go for quite very less examples. So you have to try for each example, even you have to think for the logic. What is the logic? How you can make a function as a recursive code? So we'll go for a few example later. Before that, let's discuss one important topic of recursive things. That means, what are the right or sensible recursive code? Right or sensitive recursive code means what? When we are doing a recursive code, what are the things you need to keep in your mind? That means, when you are writing a recursive case, but if there is no fruitful code, so it will either not run or it will produce a bad result. Bad result in terms of programming language is called either the loop does not end, or either the execution does not end, or sometime when program get choked in between the execution. Just like yesterday I have tried, you can in front of you, that this is one code when def A is calling B and def B is calling A. You can see, I think you can remember, it was running endlessly. So basically this type of code produce runtime error. Runtime error are types of code actually when the error, where there is no syntactical error. Syntactical error means when I am writing the code, practically you can see there is no error in my writing of code, but when I will run the code, that time whenever it is running the code, when it will reach a particular specific time, then it will stop working. So this is only called runtime code. Then coming to the next things, that whenever we are writing a recursive code, what are the things you need to keep in your mind? So first things, that is base case, and second one is recursive case. Base case, this is the most important part of a recursive function. Base case means what? Base case is the case or condition that should be present and reachable. Without this, your recursive code will not work. Because we'll go for one example of base case, and let me tell another point, that is recursive case should be present. For example, you are planning to convert any particular function as a recursive version, but ultimately if there is no recursive point, or there is no recursive way, so how a program can go as a recursive function? And second one is base case. Without base case, recursion cannot work. You know very well. Yesterday only we get the demonstration. So let's go for one example, and through this example we will learn about what is base case and what is the recursive case. So here is my first example. Yesterday we have discussed the examples, but again today we will discuss the same example. But before that, I have taken another example here. So this is one of the valid example or proper example. There is no error. And here you can say this is also an example, but here you can see there is no base condition. So the program will run endlessly, and at the runtime it will just give one error, and at certain time it will stop work. So whenever it is stopping work, it is actually called maximum recursion depth exceeded. You can note down the point, depth exceeded, EXCEEDED, maximum recursion depth, depth exceeded. What does it mean? Yesterday when we run the program, that time you can see that it was printing something in the screen, but after few minutes or after few seconds it stopped working. The console becomes stop. So that only called maximum recursion depth exceeded. That means it is actually, the code is for continuous running, but at some time or at the certain point of time it will stop working. That is only called maximum recursion depth. Actually this recursion limit can also be set through some function is there in our Python console or Python window. Through that also we can set our maximum recursion depth. Now let's go for a proper or valid example. Here my question is sum of 1 to n natural number. That means sum of first n natural number. For example, I want to find the natural number. I want to find the sum of first 5 natural number. So what my question is there, actual answer should be like this: 1 plus 2 plus 3 plus 4 plus 5. This will be my answer. So ultimately the sum of this answer, 5 plus 4 9, 3 12, 12 and 3 15. The sum of this part will be 15. So this should be my answer. So how I can get this answer? But before going to this, I will write the code and try to demonstrate using the normal approach. So let me write how we can find the sum of 1 to 5. So for that purpose, we'll write the things in a simple looping structure basis. So depth, I am taking one variable sum or simply function sum. Here I am receiving one n, parameter n. Then within the function body will run a loop. Here I will take one variable s equal to 0. So for I in range 1 comma n plus 1, simply will write an s plus equal to I, and finally we can print s. So what will happen? The value of I will be changed, just like first of all value of I will be 1. So 1 plus value of s is 0, s will be 1. Then next time s plus equal to I, that means again I will be increased, that is 2, and s will be 1. So it will be now 3. Then I will be 3 and s is also 3. So 6. Then I will be 4 and it will be 6, that is 10. Then I will be 5 and it is 10. So ultimately it has reached to 15. This is the general or normal technique or looping structure, or simply normal loop block through which we can find or do the recursion. But now we'll convert this code into a recursive technique where it will work as a normal way. So let's see. First of all, the function name I have written here def. Function name is def sum n. Within bracket I have written here n. If n equals to 1, I will come to this part later. First of all, let me go to this part. Return n plus sum n minus 1. You can see very easily sum n and this sum n is same. So I am calling this sum n function from this sum n function. That means I am calling the function from its body only. Self calling function. I am calling the same function here. And now you have to understand this point. We are beginning, for example, we are beginning with 5. We are beginning with 5. So 5 plus 5 minus 1, 4. That means 4 will be sent to this part. At first 5 it will receive. So using this 5 it will work here. 5 plus 5 minus 1, 4. 4 will be sent to this. Again 4 plus, so already n is here. 4 plus 4 minus 1, that is 3. Then 3 plus 3 minus 1, 2. 2 plus 2 minus 1, 1. And then this is the ultimate case. This whole part is actually the base case of this recursive code. This is the base case. Base case means, as we know, which actually prevent for running the recursion for infinite times. So if n equals to 1, if n equals to 1 means this is my base condition. When the program will reach to this part, ultimately it will return 1. That means when 5 will be reduced to 1, that means 5, 4, 3, 2, 1, when it will reach to 1, then simply it will find the final or actual sum, and ultimately the sum will come to s and then s will be printed. Again I am repeating, when we are writing a recursive case, you will have two case or two part. One is base condition, which actually controls the behavior or which actually controls the endpoint exit point of any particular recursive program, and the recursive function that actually calls itself. So here is our base case and here is our recursive technique or recursive function. So you can see n equal to 1, return 1, then n return n plus sum n minus 1. Constantly it will simply subtract the value. So this is our technique of sum of 1 to n natural number using recursion. Now again we will discuss yesterday's 2 program, and after that we will proceed further. So first I will discuss the factorial. First I will discuss about the factorial of a number. Factorial of a number using recursion. So let's see how it works. First of all, we know that factorial means 5 into 4 into 3 into 2 into 1. 5 into 2, 4 into 3 into 2, 1. If you have any doubt till this point, you can ask whatever doubt you will have. So, because as I am telling one thing, that this chapter is quite easier or quite smaller chapter. So, we will finish this chapter very quickly, because very less examples are there. You have to go through the examples only, because concept are basically these part, base condition part and actual recursive case part. You have to understand the chapter through examples only. So, if you have doubt, any doubt is coming, you can ask in our classroom app, or simply you can ask here also. So, just let me go to second part, this factorial. So, I am writing the recursive code for factorial. So, def, I am taking one function name facto, I am taking one fraction name facto. I think writing is clear or understandable. Def facto, within this bracket I am taking one variable n. This is simply function header. Within this part you have to write one base condition. I will write one base condition, and then after the base condition you have to write the actual recursive code. So, what is base condition? I will write. So, you can see factorial means from the number it will go up to 1. So, that will be my base condition. You have to first understand what part you will make the base condition. So, here I am writing if n equal to 1, when n will reach up to 1, so factorial of 1, it will send 1 only. This is my base condition. And now I will write on the else part, else return. Basically recursive function are of return type. Without that you can't repeat the code, because the function is calling itself. So, if you do not use this return statement, as we know function there are two types, void and non-void. So, without return type it is not possible to call the function repeatedly. So, that is why we have to use this return value or return type. So, return, then I will write n is my actual number, n into, then I will call the function, then facto, and then what will write? I have to just go to the next number. So, n minus 1. This is my recursive code. Actually, this part. This is my recursive code. So, at the beginning, and then we are returning the value, and if from the main only, if we just simply call f is equal to facto of 4, for example, and then we will simply print f. This is our technique, but let us go for the output. So, at the beginning we are sending value 4 to n. So, value of n becomes 4. So, n is not equal to 1. So, ultimately it will come to here. So, 4 into 4 minus 1. So, directly 4 into 4 minus 1 means 3. So, 3 will be sent to this function. So, 4 will be sent to this, 3 will be sent to this function. Then when again 3 will come here, 3 into 3 minus 1, that is 2 will be sent to the function again. Then again 2 will come here, 2 into 2 minus 1, 1 will send to here. Now n becomes 1. So, now n equal to 1, this condition becomes true. So, it will return 1 to this area. So, ultimately it goes like 4 into 3 into 2 into 1, ultimately it will return the value, that is 24. So, this is our second example of recursion. Now, we will go for the third example, that also we have done yesterday in practical, that is the power of a to the power b. So, let us see how it works. So, def, I am taking one simple method name power, double R, PO, 1 R also possible, no issue. Here you have to take two variable a and b. So, what will be my base condition? If the power reach up to 0, if b equal to 0, That means anything to the power 0 is equal to 1. So that's why if power reach up to 0, so we'll simply return 1. We'll return 1. If this can also happen, for an example, any user is sending to number 4 and 0. So 4 to the power 0, ultimately it will be 1. So this is the condition. So depth power, if b equals to 0, return 1. Else, this is my recursive code. I will write, what I will write, a into, sorry, return statement you have to give, return a into power of b minus 1. So 1 by 1 b will be reduced, a comma b minus 1. A is the constant part, a will never change, a will simply never change, because I want the power of a to the power b. So in that case, for example, you want 2 to the power 3. So here a is 2 and b is 3. So first 2 will be multiplied, then with 2 again 2 will be multiplied, again it will, when it will reduce to 1, 2 will be multiplied, and at last when b will be 0, so that time it will be 1. So ultimately 8 will be the answer. So this is the concept of third recursion. So I have discussed today 3 example of recursion. So as assignment I am giving some more today to you that you have to solve, and I am sharing notes and things in the Google Classroom, and you have to solve. I will send some few more questions, just like already I have discussed some of n natural number that I have discussed. Find the value of a to the power b I have discussed, factorial of a number that also I have discussed. This is one example we will discuss later, but before that also I am sharing some notes and one short assignment that you will finish and you will submit me in the classroom app only. So here today I am just closing the session. Thank you. Good day, student.